Right, the topics we're going to do in these videos are simultaneous equations, Surds, indices and logarithms functions, quadratic equations and inequalities, polynomials and partial fractions. Let's look at the first equation, solving the simultaneous equations. I'm going to provide you with two different methods, and then you decide which one you want, which one you prefer to use. Method 1 is rather straightforward. That is, from equation 1, you make x the subject. Right, so you divide by 2 throughout, you will end up getting x equals to 3y over 2 minus half. Then you substitute equation 1 into equation 2. Right, so in this case here, you have to be careful because you're dealing with fractions, you're dealing with 3y over 2 and half. So you need to be a bit more careful when you manipulate, when you expand this bracket. So y means y over 1. So you're taking y over 1 times 3y over 2. So you're taking y over 1 times 3y over 2, and that gives you 3y squared over 2. Right, so you do the same for the rest of the terms, and you end up getting whatever that you have you can see on the screen there. And the next step is I will just multiply every terms with the number 2. Every term. Okay, every term with 2. And then you end up getting 4y squared minus 3y squared plus half times 2 gives you 1. So end up getting y. Half times y times 2 will gives you half times 2 times y. Half times y times 2 is the same as half times 2 times y, and that gives you 1 times y gives you y. All right. And you will end up having a quadratic equations involving y, where you can just factorize it to find the values of y. After finding the values of y, you have to sub into equation 1 to find the values of x. So the two intersection points will be negative 12.5, negative 8, and 1, 1. All right, method 2 is I don't have to deal with any fractions. So how do I do method 2? Right, so instead of making x the subject, I make 2x the subject. But in this case here, I have to do something to my equation 2. I have to multiply every term with 2. So if I apply every term with 2, we can see that you will have this 2x here and 2x here, where you can just simply substitute it to be 3y minus 1. Right, and you end up also getting a quadratic equations involving y, and you can reduce it to y squared plus 7y minus 8 equals to 0. Factorize it. Right, let's do another questions on solving simultaneous equation. In this case here, I think you have no choice but have to make from equations 1. Oh, so we don't make y the subject, rather we make 2y. Why we make 2y the subject? Because if you look at equation 2, right, this is 2y minus 3. Okay, so it's more appropriate to make 2y the subject rather than make y. But it still end up having a fraction, so you still have to manage the fractions, no choice. Okay, this one here, we apply your algebraic identities. Your a minus b squared is equals to a squared minus 2ab plus b squared. All right, this one we combine them into one single fractions to get what we have here. Okay, please simplify 3 minus 15 as negative 12, okay? Simplify whatever you can first before you do the expansion. All right. Okay, what I have done here is that you see this steps here, okay? If you don't understand how I get these steps, it's actually not difficult. This step here, what I have done is, oh, wait. What I have done here is just multiply by 25 throughout. Can you see the denominator here is 25? So I want to make everything a non-fraction, so I just multiply by 25 on every term. Every term I multiply with the number 25. That's how I end up 25x squared minus 100x plus 100, so on and so forth. And then this one I need to expand again using your a minus b squared, your algebraic identity. Okay, put a huge square bracket here because there are so many terms involved. Anything more than 2 terms, you just put a square bracket. Okay, right. Then you simplify further. All right, a lot of numbers to see, so you need to be careful. Factorize it. You can use your calculator to help you mode 33, mode 3, mode 33 or mode 32, okay? Right, so you get x equals to 7 or x equals to negative 3, and your story does not end here because you still have to find the y coordinates because you're finding intersection points. Intersection points will have x coordinate and y coordinate. All right, so you're supposed to find the coordinates of a and b, so you just label them as, you can label 74.5 as point A. If you don't like it, you can label it as point B. Doesn't matter. Okay. You just make sure you label them lah. Okay, label the 2 points as A and B or B and A, up to you. Right, let's attempt to do another questions on solving simultaneous equations. So in this case here, I think you have to make X the subject, right? Rather than make Y the subject. Right, because if you make y the subject, then you then you may end up getting a fraction. You have 7 minus x divided by 2. And then anything to do with fractions is the chances of you making mistakes will be higher lah. Okay, because there are more algebraic manipulations you have to manage with. Right, then you sub x equals to 7 minus 2y into the second equations. Okay, and here we actually apply the your algebraic identities. Okay, to expand your bracket 7 minus 2y, cross bracket the power of 2. Right, factorize it. Find the values of y. Substitute back into your x equals to 7 minus 2y to get the values of x. Okay, so hence the two intersection points are 6, half and 1, 3. That's part 1. So for part 2, hence find the possible values of a and b. Alright, so this one you have to do a little bit of comparison. But before we do a little bit of comparison, let's try to rewrite these equations. From part 1, you have this simultaneous equation here, right? Okay, we will rewrite 4y squared as bracket 2y to the power of 2 because 2y times 2y will give you 4y squared. Okay, why do we want to do that? Let's look at the second part. Alright, so your 3 to the power of a plus 2 to the power of b plus 1 equals to 7 will be compared with x plus 2y equals to 37. And then, right, and we need to do some simplifications for the second equation so that you can see the comparison clearer. Right, so 9 is equals to 3 squared and 4 is equals to, this one here, 9 is equals to 3 squared, 4 is equals to 2 squared. Okay, the purpose of doing that is so that you can see the comparison clearer. Alright, so you can see that now you can see quite clearly comparison. There's a power 2, and also power 2 here, and then 37. So from there, you would observe that x is actually equals to 3 to the power a. You can actually compare. X is like comparable, can be replaced by 3 to the power a. And y is actually, 2y is actually comparable with 2 to the power b minus 1. Okay, so we do first part first. So Observe that 3 to the power a is equals to x, and we already found the answer for x in part 1. Part 1, we found the answer for x to be 6 and 1. So when x is 6, 3 to the power a is equals to 6, and you can bring LG or LN, doesn't matter, because you can use, on the calculator, you have this functions ln or lg to help you evaluate the answer. Alright, so for the second answer is when x is 1, do the same. So you will have two answers for the values of a. So now let's find the answers for b. Okay, so observe that 2 to the power b plus 1 is equals to 2y. Okay, and then we already found the values of y, so we just do a substitution. Alright, then you can find the values for b in both cases when y is equals to half and y equals to 3. Okay, so this is there's a star there beside part 2, means it's rather challenging, so you have to be able to see the comparison. But before you see the comparison, I've already shown you how you can do some simple manipulations, so you can see the compare and then observe it clearer. Right, so this question is on evaluating surds and is rather straightforward. Right, you just have to rationalize it with the conjugate surds. So the conjugate surds for 2 square root 5 plus 3 will be 2 square root 5 minus 3. So just multiply the numerator, denominator. Right, so this part here, you can just simply use the calculator. The denominator, you can just simply use the calculator to evaluate to get 11. Right, simplify further. Okay, there's a recap here. Okay, square root 5 times square root 5 will give you 5. Okay, square root a times square root a will give you a. Right, and you cannot leave answer as like that because you're supposed to leave it in the form a plus b square root 5, which means you have to, yes, split it into two fractions, and answer will be negative 2 plus square root 5. Right, we're going to do a rather challenging questions involving surds. There are many ways to solve these questions. Some of you may want to combine all these into a single fraction. I may not want to do that, but you can go ahead and try it out. And if the method doesn't work, then you can try to use another method. So what I'm going to do here is, instead of combining them into one single fractions, right, I actually did some simplifications here. Right here, I apply this rule, right, by writing 54 as 9 times 6. Alright, the reason why I use 9 is because 9 is a perfect square. Square root 9 will give you 3. So usually you should use a perfect square multiplied with something else. So in these steps here, I actually have done rationalization. Likewise for this also. Alright, so the next thing that I've done is, okay, I've just applied the rules that I've mentioned here. Apply this rule. Okay, to this, and also to this one here. Right. And then I simplify further. Okay, simplify further. Right, all these are perfect square. So square root 25 will be 5. Square root 49 will be 7. Then you just use a calculator to simplify with the denominator as well. Right, to get this group of numbers here. Alright, and then only at this step that I actually open up the brackets by multiplying it with the square root 2. And I write square root 2 as square root 2 over 1 to make it as a fractions, so that we can just simply multiply the numerator and multiply the denominator, right, to get this step here. And this is when I finally combine them into a single fractions, and k is equals to 7. Right, so in these questions here, I have applied rationalization. I've applied these rules, right, and also rationalization. Right, so this is a problem sum involving surds. So let's draw the triangle. Right, so we have a triangle PQR. And this triangle have area equals to 28 plus 3 over 2 square root 6. The length of sets of QR, okay, so this is given to be 2 square root 2 plus 5 square root 3. Express the length of the perpendicular from P to QR. So we draw a vertical line from P to QR. It's a perpendicular line, so this is 90 degrees. All right, and the answer you have to express it in the form a square root 3 plus b square root 2, where a and b are integers. All right, by telling you that a and b are integers, it's actually trying to help you to get the correct answer, because in the event that your a and b are not integers, then you know that there's some flaws in your working. All right, so we're going to use the formula to find area for a triangle, which is half base times height. Right, so half times base, which is a QR, bracket it because there are two terms there. Alright, it's important to bracket it. Okay, bracket it because there are two terms there. Half times base, and the height, it's a square root 3 plus b square root 2. And this will give us the area to be 28 plus 3 over 2 square root 6. Alright, so what I'm going to do is I'm going to make this guy, okay, a whole number. So I'm just going to multiply by 2 on the left, multiply by 2 on the right. And because you're multiplying with two terms on the right, there are two terms, 28 and 3 over 2 square root 6. Make sure you bracket it and then times 2. Alright, so we have 2 times half, that gives you 1. Right, that gives you 1. 1 times 2 square root 2. Okay, and then times this. Right, that will give you 28 times 2, that is 56. 3 over 2 square root 6. 3 over 2 square root 6 times 2 means 3 over 2 times 2 times square root 6, which just gives you 3 square root 6. Alright, I'm finding this guy here, so I need to make this the subject. Okay, divide by this. Alright, so what is the next thing that I do? So such is all about rationalization, about simplification. So I will rationalize it with the conjugate surd, which is 2 square root 2 minus 5 square root 3. Alright, and then this is what happened. Okay, the denominator will become this. Okay, so don't bother to, simplify this manually. You can just simply use a calculator to get an answer. Just happen that I don't have a calculator here. Okay, never mind. I just have to do it manually. If you have a calculator, please just use a calculator. 8 minus 25. 25 times 3 is 15, 6, 7. 25 minus 8. 67. Negative 67. My God, what a value. Okay. And let's simplify your numerator. So your numerator will be 56 times 2. 56 times 2 would be 112 square root 2 plus 3 times 2 is 6. 12 minus 6 times 5, 280. 280. Okay, where am I? I'm stuck. 56, 280 square root 3 minus 15 and square root 18. Oh my god, more space there, so to squeeze it. Minus 15 square root 18. Alright, I should continue here. So I would end up having 112 square root 2 plus 6. Okay, square root 12 we can simplify further as square root 3 times square root 4 minus 280 square root 3 minus 15 times square root 9 times square root 2 over negative 67. Alright, can simplify further. 112 square root 2 plus 12 square root 3 minus 280 square root 3 minus 45 square root 2 over negative 67. 12 minus 45. 12 minus 45. 2 minus 25. Right, 67. That will give you 67 square root 2. And then 12 minus 280 is negative 268 square root 3 divided by negative 67. Right, let's separate them into two fractions. Right, so you'll get negative square root 2 plus 268 divided by 67, get 4. Alright, so in this case here, you'll see that A, if you do a comparison, your A is equals to 4, which is an integer, and your B is equals to negative 5, also an integer. Right, let's do another question involving Surds. In this case here, we're given a parallelogram ABCD. We're given the areas to be 12 plus 8 square root 3. Right, the line CE is perpendicular to the line ABE, meaning this is 90 degrees here. Alright, you're given the length of AB to be 6 minus 2 square root 3. And the length of BE, this little guy here, is 1 plus square root 3. Alright, so what are we asked to find? Is to find the length of CE. Alright, so let's do a recall. But how do you find area of the parallelogram? Yes, area parallelogram is just base times the perpendicular height. So if you were to use the base as AB, the perpendicular height would be CE. Alright, so AB is just 6 minus 2 square root 3 times CE. And this 6 minus 2 square root 3, bracket it, make sure you bracket it because there are two terms there, times CE, will give you the area, which is 12 plus 8 square root 3. So to find CE is just 12 plus 8 square root 3 divided by 6 minus 2 square root 3. Right, so what is the next thing we do? Yes, it is all about rationalization, right? So we rationalize it with the conjugate surds. And that will give you 12 times 6 plus 2 square root 3 plus 8 square root 3 times 6 plus 2 square root 3 over 6 squared minus 2 square root 3 squared. Okay, so this one you can just simply use a calculator to evaluate. Alright, you don't have to stress yourself doing it mentally. That's expand the numerator. That will give you 72 plus 24 square root 3, 48 square root 3 plus 8 times 2, 16. Square root 3 times square root 3 will give you 3. Okay, and I don't have a calculator, so I need to stress myself to work out the denominator. 4 times 3, 12. So that gives you 24. Okay, not too difficult. Hang, not too difficult. The numbers are quite manageable. Alright. Then what's the next thing I do? Let's simplify further. So I will have 72 plus 48. That will give me 4 by 6, 72 square root 3 over 24. Simplify further. 72 plus 48 will give you 120. You can separate them into two fractions. 120 divided by 24. How much would that be? Is it 5? 24 times 5. Oh yeah, it's 5. 72 divided by 24, is that 3? Yes. Okay. So let's check, because both the values for A and B must be integer. So A is 5, is an integer, yeah. B is equal to 3, also an integer. So we're on the right track. So this is the answer for CE. Alright, let's look at part 2. Part 2, you're asked to find the area of triangle ADE. AD and E here. Right, this is the triangle we want to find. So this height here will be the same as this guy here. Okay. Right, so what's the formula to find area of a triangle? Half base times height. So your base will be AE, and the height will be your CE. Alright, so the base is AE, meaning you take AB plus BE. So you take 6 minus 2 square root 3 plus 1 plus square root 3. So that will give you 7 minus square root 3. Then multiply with AE. Multiply with CE, which you found earlier on to be 5 plus 3 square root 3. Okay. Right. So what I'm going to do, I'm going to leave half alone and work this out first. So that will give me 7 bracket 5 plus 3 square root 3 minus square root 3 plus 3 square root 3. So that gives me 35 plus 21 square root 3 minus 5 square root 3 minus 3 times square root 3 times square root 3. That will give you 9. Okay, let's work further. 5 minus 9, that will give you 26. 21 minus 5 will be 60. Now we can multiply with half. 26 times half will be 13. 16 times half times square root 3 will be 8 square root 3. Alright, so that will be the area for the triangle ADE. Alright, so we have done questions on Surds. Enough of Surds. Let's try to do some questions involving involving indices. Alright, let's look at 8A part 1. Alright, this question is rather simple. You just substitute x to be negative half. Right, substitute x to be negative half. So you would have before we substitute x to be negative half, maybe you want to apply this rule here. Right, to split this guy up into this. Okay, then you just let x to be negative half. This guy here, this will become this. So 4 squared is just 16. So 3 times 16 times 4 to the power negative half. Right, and 4 you can write it as 2 squared. Here you can apply this rule. Okay, 2 times negative 1 will be negative 1. Sorry, 2 times negative 1 will be negative half. So this is to the power negative 1, which gives you half. That's how we get it here. Okay. So that is 8A part 1. 8A part 2. Yeah. Okay. Again, you just break this guy out. Right into 4 to the power x and 4 to the power of 2. So that you will simplify 3 times 4 squared give you 48 here. Take 96 divided by 48 gives you 2. Okay, express 4 as 2 to the power of 2. Compare the power. Right, 2x equals to 1, x equals to half. Alright, let's look at part B. Okay, as per what we have done earlier on, we can break this guy up into 2 to the power x times 2 to the power 1. We should have it here. Right, and then you simplify it. Okay. So the next thing is just divide both sides by 2 to the power x. And here you can actually apply this. So it's all while applying the rules of indices you have learned. Same base. Sorry. Wait, hang on, wrong. This one, it's different base, same power. Different base, same power. So you can just combine them into a over b to the power m. Okay. Right. Then the next thing is that you can't express 10 as base 1.5. I mean as 1.5 to the integer to give you 10. So we will have to bring either ln, which is natural log, or lg common log to both sides. Alright, and then here you apply your power law. Okay, apply your power law. Right. And log 10 is 1. Why is log 10 1? Because LG is log base 10. So log 10 base 10. Log 10 10. Log 10 base 10, that gives you 1. Okay, if you recall this, that we've learned earlier on, log A base A is 1. Okay. So this is rather straightforward question. Right, so now let's progress into slightly harder questions where you need to solve the equations involving indices. In this case here, we will have to do something called use the substitution method. Right, but before we use substitution method, let's try to simplify this guy first. Okay, like what we have done earlier on. This one here, you can actually apply this rule. Okay, so now you can write it as 3 squared. Right, so you can substitute your x to be. Okay, there are 2 ways of doing it for this guy here. You can actually write it as 3 to the power x times 3 to the power x, because x plus x give you 2x. Or another way, it's you can write it as 3 to the power of x, then bracket to the power of 2. Alright, you will still get the same answer. So we're going to use substitution method. So you let 3 to the power of x be a, or any other letter that you fancy. You end up with the quadratic equations involving you a, factorize it. Right, remember a is just a substituted values. The original values you need to find is 3 to the power of x. So when a is 27, 3 to the power of x is equal to 27. You can write 27 as 3 to the power of 3. Same base, compact the power. Likewise for the other value when a is 3. Alright, so that's part A. So for part B, alright, so far if you were to observe what we have been doing, is we have been applying this rule, this rule here, to break the number into separate bases, and then you group all your integers and group your variables together. That means group your index on one side and group your numbers on the other side. Alright, so we've done questions on Surds, we've done questions solving exponential equations. Now let's try to do questions involving logarithmic functions. Right. Let's start off by writing down all the 3 laws that you need to remember. Besides your product law, quotient law, and the power law, you also need to know how to apply change of base. So for example, if you're given log base A, B, and if you want to change it to base C, right, this is how you go about doing it. Right, so what's go to the numerator will be your letter B, and your original base here will go to your denominator. Okay, what some other things that you can recall involving logs? Yes, log A base A will be 1. Log 1 base A will be 0. Okay. Let's see how we can go about doing this question. Right. So how do I simplify this number? 972. I would have to rewrite 972 as index notation. To do that, you can use the ladder method that you have learned in the lower secondary. The ladder methods, I'm referring to this method here. You can divide by 3. Okay, keep dividing it until you can't do it anymore. And then you use divide by 2. Right. So from there, you will be able to get the answer as 3 to the power of 5 times 2 to the power of 2. Right. And here, we can apply your product law. Right. Product law here. Okay. Apply the product law. Right. And then how do I get from this step to this step? We'll be applying the power law. Right. Then the next thing is to plug in the value for log 3, which is B, the values for log 2, which is A. And do some simplifications and you will get the answer. That is part A. So how about part B? Right, not to worry, part B. Part B, you already know that, not already know, sorry. In the questions, you're given A to be log 2, so just plug it in. And B is given to be log 3, just plug it in. So what you need to do here is, alright, you just need to combine all this guy using the laws that you have learned into a single log. So when you have a single log on the left, single log on the right, you can just remove the log, and that's how you get the values of x. So here you can apply your power law, also power law, right? So 1 you can write it as log 10. Why is it that we want to write 1 as log 10? Are you able to answer the questions? Remember what our objective is? Our objective is to convert it into a single log. Alright, so 2 to the power of 3 will be 8. 3 to the power of 4 is 81. So here you can just apply the quotient law. Alright, will gives you 8 over 81. And from there, you can, so you will have log 8 over 81 plus log 10. Right. So this step here, you can apply the product law to get this guy. And since you have a single log on the left, single log on the right, therefore x is equals to 80 over 81. Alright, let's do a next question. Alright, again, there's some recall there. Recall of some concepts we have learned regarding log. Log base A, LGA means log base 10. LG, it's a common log, so it's just log base 10. And log 10 base 10 gives you 1, so log 10, LG10 is 1. Alright. So this is important. Why this is important? Because this is what we're going to do to the number 1 there, to change it to log 10. Right, and then you can just apply your product law. Then you can apply your quotient law. And then you end up getting a quadratic equations involving x. When you factorize it, okay, remember that not all values of x are suitable. Some of the values are not valid. So how do you know which values are suitable, which are not? So whatever values that you are given, okay, always substitute back into the original equation. In this case here, if your x is negative half, right, if you substitute back into original equation, you have a log of negative half, which is not defined. Okay, so therefore x equals to negative half is rejected. How about x equals to 3? X equals to 3 would have no problem. You have log 3, okay. The next one is log 3 plus 3 log 6, also no problem. Then this guy here will be 3 times 2, 6 minus 1, log 5. Log 5 also, it's alright, it's defined. Alright, with all the confidence that we have gained in the past few questions, I think question 12 will be a breeze. Right, so let's look at 12 part 1. I find that there's certain things you can do. For example, this here, you can just apply the power law, right? But this guy here, you would have to write 81 as 3 to the power 4. Why write it as 3 to the power 4? Okay, you write it as 3 to the power 4 so that you can apply power law. And then log 3 base 3 is 1. Okay, and I bring this guy over to the other side to combine it with this so that I can apply the quotient law. Right, and if we were to remember this law that we mentioned earlier on, this rule, log a base a is 1. So basically 4 can write it as 4 log a base a, right? So depending on what base you want it to be, to use, in this case we want to use base 2, so we can just replace a with 2. So that's how I, from this step to this step, here to here. Okay, and then we'll apply power law again. Then you will have a single log on the left, single log on the left, on the right. You end up having a quadratic equations, where again you have to factorize it. Right, and you end up having two values of x. Right, and you need to check which values is defined, which is not. In this case here, x equals to -4 will not be defined, because if you were to substitute into the original equation here, you will have 2 log base 2 -4, which is not defined. So x equals to -4 is rejected. Alright, so that's part 1. So part 2. Alright, in this case here for part 2, we would bring ln to both sides. Why ln? Because ln is just log base e. So ln e is log e base e, and that gives you 1. Alright, so leave your answers to 3 significant figure. Okay. Alright, so by now you would have observed a variations of questions that you can be tested on this logarithmic functions, but you would also observe that we have been just simply applying all the product law, quotient law, power law, change of base, right? So we keep actually applying all these laws to different situations. Okay, so in this case here, I have applied power law here, and then I write 1 as log 5 base 5. Okay, and then the next step is here I can apply my product law. Here it's quotient law. Likewise for the one below, it will be quotient law throughout. So it's 40 divided by 4 divided by 5. So you write it as 40 over 4 divided by 5. So this chunk of thing, you can just use a calculator to simplify. Likewise for this chunk of thing. Okay. Right. Okay, so for part B, it's not so much about applying the laws of log. Just this one is simply a substitution, using substitution method, and you solve the two equations simultaneously. So you just substitute both points into the equations. Okay, right. So this is quite a straightforward questions. Right. The only thing that I want to mention about is if you have a situations where you have a base to the power of a fraction, let's say x to the power of 2/3 equals to 4, then how do you find x? It's actually very simple. You just bring power to the reciprocal of 2/3, which is 3 over 2, because 2 over 3 times 3 over 2 is 1. Because you're finding the values of x. X means x to the power 1, right? You want to have the power to be 1. So you multiply whatever index you have here with its reciprocal. So you have to do it to the other side also. You can't just do it to one side. Okay, and 4, you can write it as 2 to the power of 2. You can multiply the power, which is given to the power of 3 equals to 8. So this is a very, what do you call that? Very neat and useful method that you can apply. Right, so let's do some questions involving quadratic inequalities. Alright, so real roots, what's the meaning of real roots? It means the value for discriminants will be more than equal than 0. Real roots means it can be real and distinct or real and equal. So if you combine both cases, it means b squared minus 4ac more than equal than 0. Alright, so you write down the values for a, which is the coefficient of x squared, b is the coefficient of x, and c is just any other constant. Okay, and just substitute into your b squared minus 4ac. Right, simplify it. Okay, you get a quadratic inequality. Now you cannot settle a quadratic inequality the other way you settle equations. For quadratic inequality, you will have to draw a curve. And from the curve, then we determine which region we want. Because you're dealing with anything, you're dealing with more than equal than 0, means you want the regions to be above the x-axis or on the x-axis. So these are the two regions that you're interested in. So for these two regions, what are the corresponding x value? The corresponding x value will come from the x-axis. Oh, in this case here, you're dealing with k, the values of k. So this is your, instead of k x-axis, this is your k-axis. So what are your corresponding k values? So for the first highlighted region, the corresponding k values will be anything less than or equal than 1. And for the other highlighted green region, corresponding k values will be anything that is more than or equal than 8. Alright, so let's look at part 2. If the equation has no real roots, means the value for discriminant will be less than 0. Right, so if you draw your quadratic curve again, the region you're interested in is less than 0, which is below your k-axis. And the corresponding k values will be between 1 and 8. Right, so how do you know the largest value is 7? If you were to draw the number line here, so the biggest integer values for k will be 7.